Good evening, friends. Today I am going to discuss a very important concept of anesthesia, that is oil gas partition coefficient and blood gas partition coefficient. Both these concepts are very important in view of inhalational anesthetics. So first we will discuss the oil gas partition coefficient. Oil gas partition coefficient is defined as the anesthetic drug solubility in oil. Anesthetic drug solubility in oil compared with anesthetic drug solubility in gas. So this is a ratio. Oil gas partition coefficient is a ratio of anesthetic drug, ratio of its solubility in oil versus in gas. The gas oil is a surrogate marker of tissue like brain. So we can consider it oil is a lipid rich tissue like brain. Lipid rich tissue like brain. So this is a ratio of a drug solubility in oil by solubility in gas. Oil is surrogate for the lipid rich organs like brain. What it literally means that greater the oil gas partition coefficient, it means greater the lipid solubility. If oil gas partition coefficient is high, it means the gas or drug has a high lipid solubility. So it will affect rapidly to the lipid rich organs. Its potency will be high. So lipid solubility directly correlates with the potency of anesthetic drug. Potency of the drug. So oil gas partition coefficient is a ratio of solubility in oil by solubility in gas, and oil is surrogate for the lipid rich organ like brain, and increased oil gas partition coefficient indicates that there is an increased lipid solubility, which indicates that drug has a higher potency if it has a high lipid solubility. Because according to the Mayer-Overton rule, once the enough number of volatile agents were dissolved in the lipid membrane of the brain cells, anesthesia will start. So if brain cells once they receive the enough number of anesthetic molecules, then the effect of anesthesia will start. So because they are lipid rich, so those drugs who have oil gas partition coefficient high, they are highly lipid soluble and their effect will be very rapid and they will be highly potent. Anesthetic with high oil gas partition coefficient, example isoflurane. Isoflurane is a drug with high oil gas partition coefficient. So more potent because it gets more likely to dissolve easily and affect the lipid rich neuronal membrane. Its partition coefficient is around 98, very high partition coefficient. So it means it will require very low MAC to be effective. So low MAC value will be required for its potency, for its effect. So low MAC value. So oil gas partition coefficient is indirectly proportional to MAC value. If a drug has a high OGPC, it will have low MAC value. It means it will require lesser concentration to give the same effect. It will be a better effective drug. Now one more term that comes in our mind when we discuss inhalational agents is blood gas partition coefficient. Blood gas partition coefficient. So blood gas partition coefficient is also a ratio between the solubility of the anesthetic drug in the blood by solubility in gas. Or in other words, concentration of the drug in the blood by concentration of the drug in gas. This is the ratio. The concentration of the drug in the blood by concentration of the drug in the gas. It is the symbol is lambda. High lambda means high solubility in blood. If the blood gas partition coefficient is high, it means high lambda, it means the drug is highly soluble in blood. It means it will take time to go to the target organ and be effective. So if it get dissolved in the blood more and more, so it needs time to go to the effect to be effective. So it will become less potent or prolonged effect. It will have its effect, prolonged effect, delayed onset. So halothane is more dissolved in blood. Halothane is more dissolved in blood. So it will require time for the onset of action, and similarly it will require time for its effect to be offset. So high lambda means less potency and take time in action onset. So halothane is example for that. Halothane, so it takes time onset and its removal is also takes time. Similarly, the drugs with low blood gas partition coefficient has opposite property. They are fast acting. Example, desflurane. Desflurane is the example, and nitrous oxide is also an example of that. When we compare the different blood gas partition coefficients, isoflurane 2.4, 1.4, sorry, halothane 2.4, halothane 2.4 and isoflurane 1.4, sevoflurane is 0.66, 0.64, and desflurane is 0.44. These are approx values for comparative analysis. Now you can see that halothane has very high blood gas partition coefficient, so it is highly blood soluble, so that's why it is not so rapidly acting. This is the rapidly acting drug, and this is moderately rapidly acting drug. Now faster, so this drug has faster induction time, and faster offset in comparison to halothane. Let's compare the MAC value with oil gas partition coefficient and blood gas partition coefficient. Oil gas partition coefficient and blood gas partition coefficient. First, we'll talk about nitrous oxide. This inhalational drug has a very high MAC value. It's around 104. So very high MAC value. It will require very high concentration to be effective. So that's why it's a weak anesthetic. Oil gas partition coefficient is 1.4. That is also low. So if the oil gas partition coefficient is low, it means drug is more potent. It means it is highly soluble in the lipid, so it is having more effect. So it's a weak drug but potent drug. Sorry, it's a less potent drug because it's a low oil gas partition coefficient. So it's a weaker anesthetic. Blood gas partition coefficient is 0.47. It's also a low value. So low value means it is a rapidly acting. It's a rapid acting. On the one hand, it has a very high MAC value, very low 1.4 oil gas partition coefficient, a weak anesthetic with low potency, but it's very rapidly acting. So its offset and onset will be very fast. For desflurane, MAC value is 6.0. and oil gas partition coefficient 19, and blood gas partition coefficient is 0.42. So moderate MAC value and low oil gas partition coefficient and low blood gas partition coefficient. So rapidly acting drug with fast onset and offset, moderate potency. Sevoflurane 2.0 MAC 50 and 0.65. It means it has a low MAC value, very strong anesthetic, more potent, and it has a moderately high value for the oil gas partition coefficient. It means it is potent drug, and it's a moderate rate of onset and offset, rapid to moderate rate of onset and offset. ISO 0.75, 224, 98 and 1.4. 0.75, 98 and 1.4. So low MAC value, very strong drug, high oil gas partition coefficient, potent drug, and blood gas coefficient is high. So it's a slow induction and recovery. Slow recovery. Halothane has 0.75. Sorry, I have written here the MAC value is wrong. It's 1.15 and 0.75 is halothane, because halothane has the lowest MAC value, 224 oil gas partition coefficient and 2.4 blood gas partition coefficient. So low MAC value means it is also very potent drug, very strong anesthetic, highly potent, but slow onset and offset. Now one more drug I want to discuss, that is a special drug, and it has something special into those concepts. This is Genon 0.15 MAC value, 0.015, 2.0 oil gas partition coefficient and 0.115 blood gas partition coefficient. Highly potent, okay, highly potent drug, but moderate lipid solubility. According to oil gas coefficient 2.0, it is 2.0 is low value, and low value means low potency, but it is highly potent. I will explain it just a bit later. And rapid induction and rapid induction. So highly potent drug with rapid induction and rapid offset. But here the oil gas partition coefficient is low value, which indicates it is of low potency, but it's not. In case of xenon, the oil gas partition coefficient MAC values do not clearly indicate, they are somewhat contradictory of their Meyer-Overton rule. So Meyer-Overton rule is not a absolute law. It has many loopholes. So in case of xenon, it is not applied here, because even if the oil gas partition coefficient is low, the MAC value is very low. That's why it is very highly potent drug. It's because of its mechanism of action. So mechanism of action is NMDA receptor driven. NMDA receptor driven. And all other, except the nitrous, all other volatile anesthetic drugs have a GABA A receptor mechanism of action. Now, because it acts on NMDA, it acts very rapidly. Its action is very fast, because NMDA, those drugs which act on NMDA have very rapid action and rapid offset time. So, because of this receptor, this xenon is very highly potent drug. Thank you very much.